Good day, everyone. How's it going? I thought I could give the presentation about rapid speciation, okay, rapid evolution. Somebody left a comment saying that Mark Reed, during his debate with Kent, was going over a good point on how we believe in rapid evolution. And I thought I needed to respond to this, so I am going to. And in doing so, I actually decided to watch the video so I could get the timestamp. And without a lot of time to do this, I went as fast as I could through the video, and I couldn't find it, but I found a lot of other good things. So before I get into the presentation, I'm sure it's going to get into it a little bit, but we're going to go over a kind of a review of the things he was talking about because I can't help myself. And then at the same time, we're probably going to get into rapid speciation. So I hope you guys enjoy. And we will go over the timestamps. I just left a comment down here on Standing for Truth's video during that debate, so I can find these timestamps. So you guys don't have to worry about following along. I'll just make sure that you guys can hear everything good. And the first one is real quick. Actually, I got to slow it down. Have it on 2x speed. And this one goes for a little bit less than 2 minutes, but there's a lot packed in here, so enjoy.
For evolution. Now, the first off is genetic similarity. We are 95 to 98 similar, depending on the genetic code. So this is humans and your closest relatives, the chimpanzees. Now, the thing is that, like you're closer to your sister or your brother, as you get further away, like you'll be less genetically similar to your cousin, say, than your sister or brother, and then less genetically similar to the next distant relative, just say your second nephew on your mother's side or something like that. That's exactly the same thing we see in animals. As we get further away from humans under the evolutionary model, the less genetically similar we are to them. And don't forget, we had the evolutionary model before we had genetics to confirm it. In fact, the creator of evolution, famous Darwin, he didn't even know about genetics. So that's just backing up what we've already found. Now, I've just included a couple of papers here, just pointing out that they're, almost identical, depending on how you evaluate it. 99 to 95% similarity. And I've just included those to show that there's a great similarity between them. This isn't a coincidence. And the way that animals are similar, that we found after we found genetics, shows that the model is true. And those were testable predictions. We predicted that they would be genetically similar.
And that, my friends, is 100% wrong. That was actually never predicted by evolutionists. It was predicted by young Earth creationists, and it was way earlier. The predictions from evolutionists would have been true, but unfortunately, deep time is not true. So for them, it's what failed. They said, if deep time is true, then the mutation rate that's ticking over would have separated everything that should be related, and it would disperse them. So there would be no point in actually trying to find any genetic similarity in species. That's what they predicted. And then they actually found that it was actually highly related, and therefore their prediction was a falsification of evolution, and now they use it as the best evidence for evolution. So he was completely wrong, 100%, and they've had to backpedal, and now, of course, nobody knows the original thing about that, which is pretty funny to me. But regardless, he completely started off wrong, which is no surprise that he doesn't know this. Most people don't. They don't research, right? They're just, whatever we're told in school is what we believe. So he didn't dig deep at all. It's okay. You don't have to, but when you're going to be in a debate, it's usually good to know, like, if you're literally opening your presentation with a wrong statement, something that literally proves the rest of your theory wrong. Genetic similarity shows a common designer, and the fact that we are so genetically similar is a complete destroyer as well. And plus, here's another thing. When you test for a paternity test to determine if somebody is your cousin, guess what? They test the mitochondria and they test the Y chromosome, and it shows that they are humans. They're testing the protein coding genes to determine whether or not we're related to chimpanzees. So they're not using a maternity test, which shows genetic relations. Because if you use a paternity test, there is nowhere you will ever find you're related to any primate, only humans. So couldn't even get that right. But let's move on, because this is not what this presentation is about.
But you're basically, we've never seen something copied and turned into something else. What I want to ask you And you've already admitted that we do see animals changing over time. A dog breeder will change dogs over time. That is something that we all see, and you're not even disputing it, and I understand that. But for us, where is the physical mechanism, and can you demonstrate the physical mechanism for putting a limit on change? You can point to papers, you can point to research, you can provide your own research, but where is, because a cow jumping over a moon, we know that in physics there is a physical limiter to how much muscle mass you can get, how high that you can translate that energy into. There's a lot of physical limits that we can absolutely describe using physics and
Okay, so he wants to know what's the genetic limit. Where does evolution stop happening since there's mutations, right? So I answered that actually just right here so everybody can see. The physical mechanisms of change. Well, we look at breeding for that. We can look at domestication. We can look at hybridization of animals, and we can see the physical boundaries that occur from something like that. Of course, we have to get into the genetics, of course, but humans ignore the fact and have limits in the lab. Oh yeah, exactly. We don't have to watch nature to determine what the limits are. If we get into a laboratory and we can experiment on something, we can rapidly see the difference after just a few generations, because we can use radiation to induce mutations. We can control the environment. We can raise temperature, lower it. We can impose oxygen. We can deprive them of food. We can we can inject things into them. We can see the massive variety of something in a very short amount of time by using things that have short generation times, like Saccharomyces cerevisiae, which are yeast, which are eukaryotes, by the way. We can use bacteria. We can use these things, and we see the genetic limits. And mutations, do they have limits? Of course they do. We know that they have limits because they have limits on where they occur. They're called mutational hotspots. We also know that they have mutational load count, meaning in the mitochondria, you can only get a certain amount of mutations filling up the mitochondria before they just start flipping over. That's another way we know that the human genome is young, because, or any animal in the animal kingdom is young. It's because genetic similarity is still getting larger. So therefore, there's not mutational saturation in any living species today. So yes, we're going to get more into that, but I digress again. I was actually looking for this. Apparently, Marx stated, we believe in rapid evolution. I said, well, that's equivocation, because in his mind, speciation from evolutionist mindset is what leads a land animal into a whale over time, or a bacteria into something else over time, through beneficial mutations and speciation. They believe this is a slow process because beneficial mutations have to reach fixation. Therefore, they are taking their paradigm and putting it in ours, and that's their mindset that they're coming from. So they go, you guys believe that all the animals got off the ark and created every species that there is today. So therefore, you must believe in hyperevolution. We do not believe a species will become a different kind. Of course, they will say they will always stay in the family level and never evolve out of it, from it, behind. They'll never go in reverse, or what's known as de-evolution and molecular evolution. And we will get into that because that's actually part of the presentation. I just wanted to go through some of these things that I noticed. I didn't leave a timestamp here. 1:33:55.
Is that going to add something new? Is this an example about it's going to turn an amoeba to a whale over trillions of generations? You can believe that, but that's not science. So I have nothing more to add to that one.
Okay, thank you. Mark, quick final word. Mark, I'm not sure why it's not letting me unmute you. It keeps saying that you mute.
Definitely. No worries. Thanks. Anyway, yeah, we don't see an amoeba turn to elephant, nor
Hand it over to you if you had
Anything more to add to that one.
Okay, thank you. Mark, quick final word. Mark, I'm not sure why it's not letting me
I must have messed up with that timestamp. That's not what's being said here. We'll just go on.
happen. So I would probably sort of, make the distinction. Well, you believe in God creating everything. When have you seen something being created by God?
God created everything in the book of Genesis before man ever even existed. So even there was only one thing that any man would have ever seen created, and that would have been Adam, and he would have got to witness Eve being created. But it says that God placed him in a sleep and then removed his ribs. So Literally, I don't even think Adam got to witness anything God created. So no one's seen it because it took place in the beginning during creation week. So we don't have a view of these things. And then today we're in God's Sabbath. So God is resting. So obviously he's not creating anything new. That's pretty simple. So move on.
Fossils like Archaeopteryx. It's basically a bird with all the characteristics of bird, but it still has the teeth that we would find in dinosaur. It was predicted. I believe it was Darwin, I could be wrong on that, but it was somebody that predicted that if evolution is true, then we should see a bird with teeth that dinosaurs evolved into, avian forms. And we did find multiple examples of Archaeopteryx, which is almost perfectly in between a bird and a dinosaur.
Unfortunately, Mark doesn't keep up with these things because they've actually found Archaeopteryx in the layers deeper. According to their paradigm, the deeper layers are older. Well, they found Archaeopteryx before the very therapsids that supposedly it evolved into. So Archaeopteryx is dead evidence for them now. He's not up to date on it. It's okay, though. It's okay.
Now, beneficial mutations. I mentioned tetrachromia earlier in women that gives them extra eye receptors. That is a beneficial mutation. In fact, after there was a car crash in America, they tested these people and found that they had a gene for higher bone density. Their bones are stronger, and they do not. All of them came through a horrific crash with no broken bones in people.
Okay, so they had a gene that helped with bone density. He doesn't realize that that gene was already there. It's an epigenetic regulation that stayed on to allow people to have stronger and better genes. This is an epigenetic regulation. The gene didn't mutate. It's not a beneficial mutation. And you can actually read the paper called "You Were Not Born with the Bones That You Have." So literally, it can happen in your lifetime. It's an epigenetic change. It's what they've discovered is two identical twins can be born and have the exact same DNA. One will choose an entirely different lifestyle of drugs, alcohol, partying, and the other one will choose healthy benefit of life and exercise. The healthier one has the results that are different with different genes being turned on that are more beneficial because of epigenetics. Simple. So I didn't mean to go through all of that. I'm sorry. I was just looking for a specific argument that was supposedly brought up in this debate, and I couldn't find it. And it goes about how do we explain rapid evolution from a young Earth creationist paradigm? And I would have to say that this is more of a miscommunication, because when we look around the world, we see a lot of different species. Okay, now this comes down to the idea of the mindset. Even in the evolutionary communities, there's something called lumpers and splitters. So what we do is, as a young Earth creationist, we would say that God took a particular cat kind on the ark. It got off and it speciated fairly rapidly through punctuated equilibrium and rapid radiation via the mechanism that he was asking for earlier is recombination and gene conversion and epigenetics. And these things are really fast, which I'm going to show you in my presentation. Now, because these things are occurring rapidly and fast, they're actually going to be even faster in an empty world. So I want you to imagine if animals today, which are already filled in all the different niches around the world and in their environments, yet we see rapid speciation happening today, then imagine an empty world where animals literally get off of a boat in one region of the world and then migrate and diversify and fill up an entire world of different environments. Imagine how fast they would be adapting to new environments. As you're going to learn, it only takes a couple generations before speciation happens. Now, does speciation lead to different things now outside of what they already are? No. And we're going to go over that and why and how, and that there are limits and there's definitely boundaries. So I just wanted to get that into your mind that this is what's occurring. There's a mechanism that goes on in our model that says it's fast, and evolution says, no, this is required from beneficial mutations, and it takes a long time, especially based on fixation of these mutations. So I'll move on. Sorry, I'm not watching chat. I'm just kind of brainstorming over here, going on tangents. So this presentation I would be calling Genesis Genetics, and we would say that evolution says over time, all of these things are related to one another. There's a linear evolutionary chart in every school book on Earth. So when they say evolution has no direction, well, You can tell that to whoever you want, but you better tell the people that write the school books, because they show that there's a direction and it goes from primitive life to advanced life. We say that things can change, but they stay within their family, what they are, general. And we say that evolutionists have always predicted gradualism. You wouldn't see much outside of gradualism over time. It was what was predicted. It's even known as Darwinian gradualism. And then what do we find in the fossil record? We find literally everything but that, right? We find there's rapid evolution, right? Where things just spring up, where there's no ancestor to anything. And then we find complete stasis, known as living fossils, where just a small amount of speciation happened, right? Where their modern ancestor today is just a little bit different than their past one. So, Darwinian gradualism died. The Darwinian single tree of life died. And there's no universal common ancestor to even proteins. And since we know proteins don't change, well, that destroys the whole basis for evolution. Then we get into how fast is speciation. Hopefully these are in the right order, but here's 5 white-tailed deer. Only one of them was a male, and they were dropped off 80 years ago in Finland. Now there's over 100,000 of them with 5 different species in 80 years. Of course it can be fast. Of course it can be. Here, 2 sheep were dropped off, and they can only be reduced to inbreeding, right? In 1957, they came back after just 40 years or 20 years. They were fluctuating between 300 and 700 individuals. It would go up and down between that number. And sheep are nomadic. They like to travel and migrate over the continents. And they are in an unideal situation, isolated on an island, and they're still thriving, and they're still growing in populations and speciating. It's no big deal. It's rapid. How about cats? We know that there's around 40 extinct species of cats around the globe. Okay. Now, how about this? When we got into breeding, it was real fast. If we see down here, more than half of the breeds recognized by our cat association have existed in less than 100 years. And that's right. That show they had 170 cats that were exhibited. That's an insane amount of diversity in a short amount of time. And it's because humans were like, oh, I like little tiny cats with no hair on their bodies. Oh, I won't like cat to glow in the dark. Name it. I don't know. But we're able to modify, but not get outside of any limit. We can't say, I need a cat to, look like a dog and have the characteristics of a dog. I want it to even bark. That's it. Mutate away, but I don't care if you bombard it with radiation. Just give me what I want. We can't do it. There are limits. And how and why, again, we'll get into it. But how about cats, for example? So if a cat was on an ark and it got off and it was diversifying, speciating, and doing all these different things, what would we be able to see? Well, look, a tiny cat today, your house cat, is literally a small scale of a larger cat that we see outside. We can see the variation, and the variation isn't very much. Now, it is a lot in some species, but it's not in cats whatsoever. They share almost identical structures down the line, and morphology can change a little bit, but there's no real change of them becoming something else. Nobody can ever predict what a cat is going to evolve into, and that destroys evolution because they have to be able to make predictions on their theory. What is it going to become? Go ahead and tell us right in the description box below. What's a cat going to evolve into? Be the first one to make an accurate prediction for evolution, because you guys have been failing miserably so far. Here's a bunch of cat skulls, for example. Look at them. You can pick them up worldwide, and they have identical features. These are very, very similar. You can graft the skin off of your house cat and put it on a lion, and it will take. They can all breed, if not physically, in vitro. We know that they're related because that was it. Now, can they get scrambled and lose some of the information over time? Because, that's what sexual reproduction does. It takes half the genome from a parent, a mother, and a half from a father. And so that way, if there's a mess up in the genome somewhere on one of the sides, it'll be okay, because the damaged side will get boosted up a little bit by the side that's not damaged, and the species can live on. That's what's really good about it. But over time, when you get a lot of scrambling like that, of course, they might not be able to breed with one another. So evolution comes along and they go, you see, maybe over billions of years, if we just add a whole lot of time and a whole lot of imagination, we can turn that cat into something else over time. And it will evolve the ability to swim to another continent and get rid of its arms and legs, or maybe even hollow out its bones and fly there over time, right? But we say, no, that's not what we're going to see. We see one type of cat, whatever kind it was, on the ark get off, and now it explains the diversity of cats that we see. The fast mutation rates, the few amount of total mutations that are in these species, we can make these predictions. And Standing for Truth and I literally have a submitted thing that you guys can read on the predictions that we made on this and why genetic diversity is still increasing. If deep time was true, genetic diversity can't be increasing because it would have reached its peak of diversity already. Look at all these different dog breeds, right? All of them. Are they related? Of course they are. There's a little bit of variety in there, isn't there? But look, we can literally see the change over time of the skull, the shape of it from 1931 to 1976. Now, is it what's going on here? Like, it's real simple, right? Epigenetic changes. It was in its environment. People got rid of the characteristics of it having long. They wanted a shorter snout, right? Something that looked more appealing when it was alive. So in short amount of time, they took those genetic traits and they bred them out. So we were left with this more recessive-like trait through epigenetics, and it happens fast, right? How about bees? How come there's so many different species of bees? There's 16,000 known bee species. Well, how come there aren't that many with dogs? Well, because they have a higher generation time. Bees leave tons and tons of eggs. Look at this. One queen leaves 2,000 eggs in a single day. So of course, them going all around the globe and leaving like thousands of different young, you're going to get a lot of variety of different species. Now, are these different species? Again, I say no. An evolutionist will come along and they'll look at every single one of these cats and they'll say, every one of these is a different species. Every single one of them. So therefore, that number of speciation is very high. And the evolutionist says, see, you believe in rapid evolution because you believe in all these different species. No, we don't. Those are not different species. They were cataloged as different species. But remember, there's other evolutionists that would classify all cats as the same species because they can interbreed, because they have the same characteristics and traits, because you can skin graft and they all take. They all are related. They're not different species. But the evolutionist wants to classify them as different species, so therefore they will. And therefore that number of how many species there are goes up and up and up and up. Now, same with bees. You could take different bees from all around the world. There's still bees, but yet how many different species are there? 16,000? I don't think so. There's still bees. They're all still related. They can still interbreed with one another. They're still the same bee that was on the ark, just adapted to the new region that they live in. And they're still bees. They're not going to become something else over time. And their genetic limits and their genetic boundaries won't allow it. And they're not very strong either. I mean, where the temperature's gone up, universal like 2 degrees and we're losing them? Yeah. Not a very strong species, especially if you want us to believe that this honeybee survived for millions of years through multiple global bottlenecks where there was massive fluctuations in temperature. Come on, they're dying from a trivial couple degrees in temperature. They're not surviving hundreds of millions of years through hundreds of bottlenecks. That's just ridiculous. Now, let's get into rapid speciation where they admit this, right? Animals are evolving faster than you think, and here's the living proof. So Darwin considered that evolution is a very slow process, the outcome of which would have taken much more time than in a human lifespan. Of course, Darwin's assumption was making sense of things in the scientific context of his epoch. But the field of observation and experiments conducted over the last 40 years have shown us that animals often evolve very rapidly indeed. Life, it seems, never stays still. Now we're getting somewhere. So let's look at plants. What do they say about plants? Look at this. More and more evidence is showing us that rapid evolution can occur in as little as 10 to 100. What is this? I got to shorten it up a little. Generations, I'm sure, are years. It's really, really fast. This whole slow evolutionary idea is dying, and it's gonna be dead real soon. Here's the one on more plants, right? We're finding this rapid evolution can be remarkably common in introduced plant species, right? So you take a plant, which have a very large genome, by the way, because they don't move. So they have to be very adaptable to different environments. So you take a plant and you put it somewhere else and it rapidly adapts to that new environment, right? These mutations aren't as random as they might let you think. So we're going to get into that. And then we have epigenetics. So here's Darwin finches. Right? Darwin's finches are named after him and his predictions that he made. He's predicted, based on evolution being slow, that it takes one species of new finch every 3,000 years. Now, we're going to get into how wrong he was in just a minute. So this is epigenetic regulations through DNA methylation, which is controlled by a lot of B vitamins and zinc finger. And he believed, also many believe in rapid adaptation in new environments. There's a conclusion. In summary, our study documents local population epigenetic variation within 2 species of Darwin's finches. Now get this. Okay, epigenetics again is turning genes on and off. That's all it is. It's not evolving new genes. It's not getting rid of genes. That's all it does. It's a switch for them. Now here it is. Okay, here it is. Here's the death blow. Studying Darwin finches reveals that a new species can develop in as little as 2 generations. Think about that for a minute, right? 2 generations. Darwin said 3,000 years. It happened in less than 3 years. Darwin is finished, guys. It's over. This deep time nonsense is dead. This is literally the death blow. How do we account for so many species as a young earth creationist? Easy. These aren't different species, but if you want to classify them as one, as being a splitter, then easy. It happens in 2 generations. And then how come humans aren't speciating, right? You're going to tell me that these people isolated on islands like in Australia, where the Aboriginals lived there for supposedly 30 or 60,000 years, for thousands of generations, we come along later and we breed with them and there's no new species? Come on, get out of here. So again, here we go. I'm going to shrink this up. My bad. It goes off the side. In the past, scientists believed that larger animals could not respond or evolve quickly to invasive species, he said. Now we are waiting to see how this bird will continue to change. That's right. We're going to watch those little changes that allow it to be considered a different species. You know, it'll be a different color, kind of like in Joseph with the flock, right, where they grew different colors and freckles, and then they were considered a new species. The same thing. Darwin's finches will have a different beak shape, and bam, new species, right? So how many true finch species are there? 233. Can we account for that in such a short amount of time? Can we account for that? Well, let's see. If they, let's see, a new species of finch every 2 years. There's 233 species in the family today. We can account for half of them dying from extinction from that time. Oh, look at that. We could easily account for the diversity. Our model can account for it. Can evolution account for it? Absolutely not, because if you're getting a new species every 2 to 3 years, and it's happening every 2 generations, and there's finch species everywhere, there would be millions of finch species, if not more. But yet, we don't see that. We see our numbers, and we're going to get into that again. This is an epigenetic thing. I obviously put that wrong. How about horses? Okay, we've got horses. How many wild versions are there? Not too many, but yet we started breeding them. Now there's tons of them. What can we get with these horses? What is the maximum variety? Can we see a dead horse and go, yep, that's a horse based on morphology? Of course we can. What is that horse going to evolve into? Again, make your predictions if you think you got evolution down. What is it going to evolve into? I dare you as an evolutionist. Make some predictions. Come on, put your money where your mouth is. You believe in the theory. That's where your faith is. That's where your bet is. You're basing your eternity off of Christianity being wrong and that God didn't design these things, that they evolved from an amoeba. Then bam, put your money where your mouth is. Go ahead. What are these going to evolve into? Make a prediction. Come on. How long? Come on. 2 years is a new species. How many species until we don't have the horse anymore? We got something else unique. What's going to come from them? I'd love to know. They've been breeding horses for racing for a really long time to get the fastest animal they can. They can't do it. Okay, so what's going on? Maybe you can at home, sitting around doing nothing, right? How about this? Invasive animals can rapidly adapt to new environments. Oh, what a shocker. Here we go. Researchers who once assumed evolution required millennia are documented species as adapting in mere decades or even shorter amounts of time. Adaptation is happening right under our noses in our lifetime. Species are evolving at speeds faster than Darwin could have ever imagined. And this is in an evolutionary, that's in Discover magazine, by the way. So I'm trying to hurry. Someone's going to pull in a minute. So what are we seeing? We're saying recombination. The information is inside of them. It's being scrambled. Most of the mutations aren't good. Where's the bat ancestor? Where's the mutations that are leading from this to this? It's in the classroom. We've never seen it. It's not anywhere. Here's what we see: 4,675 species, right? But how many should there be if they're speciating at one new species a year, like what lizards are seen to do? Oh, there should be tons. We don't see that. We see young Earth creation numbers, everybody. And there's a fossil record that they live and die by. And then we have the waiting time problem, okay? Where can mutations, natural selection, drift produce these new genes that are required for these new functional things to occur? No, we see rapid mutation rates, and then we see the estimated one based on evolution, but we're not getting the same outcome, right? Dr. Jensen's 3 mutations per generation on the humans. We see mitochondria not full. We see, like down here, this is between humans and chimpanzees. We only see a few mutations, but yet there should be complete saturation of the mitochondria, what we were talking about earlier. Then we see, why aren't we dead 100 times over by Kondrashov? He brought that up when he saw how fast the mutation rate is, right? And then we show that there is a waiting time problem, becomes very severe when even more than one mutation is required to establish a new function. It's interesting that they admit these things. How far back do we go before we start seeing these horrible mutations arise? Look at that, 200 to 400 generations. That goes right back to Noah, doesn't it? So it seems like all of a sudden, his high age when he had his offspring created massive amounts of new harmful mutations to enter the population right around when Noah's Ark was. What are the odds of that, right? So no new mutation has been observed to add information. What do we mean by add? Well, scrambling the data that's already there to be able to produce something new, right? What have we found? Dr. John Sanford was proven right. Silent genetic mutations are harmful. They're not neutral. This is a new study. You guys can type this in, look it up. I already posted it as a community post so you guys can see and go to the links, right? Look at this. Has generally been assumed to be neutral. So, or nearly so. To their surprise, look at that. 75.9% of synonymous mutations were significantly deleterious, but selection can't remove them. So it's a presumption that these mutations were just neutral. Because selection could not see them, they were assumed to be neutral. John Sanford proven right again. Our results implied that these synonymous mutations are nearly as important as non-synonymous mutations in causing disease. So it's amazing. So natural selection is something that we believe in, the evolutionists believe in, but it doesn't do what they need it to do, or they think it does, right? And here's an evolutionist literally admitting that right here. We'll read this together. Although random mutations influence the course of evolution, their influence is mainly by loss, alteration, and refinement. However, did that one mutation make a wing, a fruit, a wood stem, or a claw appear. Mutations, in summary, tend to induce sickness, death, and deficiencies. No evidence in the vast literature of heredity shows unambiguous evidence that random mutations itself, even with the geological isolations of population, lead to speciation. Incredible admission right there by an evolutionist. So, in closing, what evidence do we have? We have the genetic evidence going back with mutation rates. We see genetic limits and boundaries. We see if we take the population that is there today. I mean, humans breed extremely fast. We grow in population extremely fast. So if human population was more than 4,000 or 5,000 years old, we would have massive more population than we actually have. Then we go into the history books and look, 5,000 years is about as far as we go back. Then we go to ancient history. Even on Wikipedia, they admit, look at that. The lifespan of recorded history only goes back 5,000 years. Then we go to civilizations and cultures, 5,000 years, 5,000 years. Another more cultures, more civilizations, 5,000 years. Why is that? Everything just explodes right after Noah's flood. And then we go to the oldest trees. Oh, look at that. The oldest trees go right back to the exact same time period. What a shocker. I'm sorry. I'm just being facetious and ridiculous at this point. And then we have, how about mathematics, right? Math must go back before written language because you need numbers for things, right? Calculations. You got to be able to do things. Nope. Goes back to the same time period. How about writing systems? Oh, you think that would go much later than speaking, right? You think you would have language and then much later you would evolve writing. Oh, same time period. What a shocker. And how about the magnetic decay rates, right? Oh, same time. How about genealogies? You can change the genealogies going all the way back in an unbroken chain from the lineages. This is the British King's List that hangs in a museum that you can literally trace modern day people going all the way back in time to the ancient writing actually that they used to connect them all the way back to Noah. Incredible. Mutation rates, like I was saying. Here's one of them. This is just a Parsons study, 1997, that he got 6,500 years using substitution rates, not just mutation rates, which is a population thing. So it's much more accurate. Then evolution predicted that there would be much more genetic diversity, right? Much more. They even admit it is thought we split from a common ancestor with chimps and humans 5 to 6 million years ago, more than enough time for substantial genetic differences to develop. So where are those differences? They're not there. The literal fact that we have so much genetic similarity is actually what destroys evolution. So it's funny. We predicted the genetic similarity, predicted there would be few genetic similarities, differences, and we were right down the line. It's amazing. Young Earth creation is just so dominant right now. It's sad that they don't notice it. And here's the sweeping gene study. And look at this, another unexpected find from the study. Species have clear genetic boundaries, and there's not much in between. The absence of in-between species is something that also perplexed Darwin. Boom, game over. And this is a brand new study, 2018, right? 90% of all life, genetically speaking, is roughly the same age. What do they mean? It means all of life funneled down into just 10% and then exploded. And now 90% of all the life that we have today came from those 10% of animals that were on the ark. And there's the genetic evidence to prove it. Simple. They come from the lens of deep time evolution when they look at these geologic layers, and they're not willing to accept the paradigm of looking at it from another perspective. And that's their biggest flaw. They put free thinking stickers on their lockers, and they're the most biased, indoctrinated group that there actually is. They will never take the perspective of ours because they don't want to. They've already made up their mind. Science is real. Evolution doesn't belong in the same category because it requires millions of years and imagination to actually get what they have. What do we observe? What we test and what we see and what we can repeat is what we do in the laboratory, is what we do in the breeding fields. And that's what we see. That's what we can make predictions on. Evolution has been failing down the line. So what are we going to trust? What are we going to believe? I don't know. How about the fact that what has been predicted and written in scripture has been true down the line? Or you can just go with one that keeps rewriting the evidence after it's already in and failing on every prediction that they've ever made. Evolution, completely blind faith, but yet they believe that there is no God. Anyway, guys, I gotta go. Family's home. Hope you enjoyed my rant. Bye.